Then types of forces acting on a body we generally categorize into two types, that is applied and non-applied. Applied means that the force that we apply externally, and a non-applied means that is nothing but it is available internally, like weight and reactions. For example, if you keep one object on a floor means it would have some self weight which is acts downwards, and this self weight would create a reaction opposite to the surface of this object, that is called as normal force, normal reaction force. We can say in both ways. And if one force is applied in this direction means, instead this P means, there might be another force which acts opposite to that motion of object, that is a friction force. So in this force system, the weight and normal reactions are non-applied force, and this load is applied force. And the friction doesn't comes under this both categories, or we can call it is an non-applied force which is created by an applied force, like that we can mention. So then what we are going to see next is free body diagram. Free body diagram means if a system of object has multiple force acting on that means, if you want to separate or isolate one object from that system of force means, we can use this free body diagram. Why we are separating one object from entire system means, we need to analyze what kind of force acting on that body, then what would be the effect. To study that only we are making a free body diagram. So before going into free body diagram, should know what are the types of forces might act on the body. So as we already saw here, these are the forces that might act on one object. See, if a car is moving in this direction means there might be some force in this direction, and opposite force will act in this direction. That is a friction force. It has some self weight that will act downwards, and a normal force will act towards the surface of the car or a wheel. That is the normal force. So if consider that there is one string is attached in the wall means, to the car which is moving means, the tension would be created in this directions. So these might be the force which act on one object. To draw a free body diagram, this object means, if you take means this object means a tension, and external load. If P is greater than D means the object will move in this direction. So friction will also in this directions, and the self weight and a normal force. So these are the very important forces in a free body diagram, and a free body diagram is mainly used to isolate one object from entire system. So we can analyze the force acting on that. So thank you. This is all the things that in the concurrent force system. In concurrent force system, in the first video we have seen what is resolution of concurrent forces and what is the importance of it. To find resultant, we are calculating the resolution of forces and equilibrium conditions, that is f of x equal to 0, f of y equal to 0. That means force acting on the x and y direction should be 0, then only it could be equilibrium, that is stationary. Then types of force acting on the body, that applied and non-applied forces, and free body diagram, why we need free body diagram, and what are the important force that we are going to consider in a free body diagram. So thank you.